Have you ever been staring at your terminal, you see that string of RWX characters and you just kind of think, what in the world is that? Well, you are definitely not alone. Those cryptic letters are basically the keys to the kingdom when it comes to system security. And today, we're going to pull back the curtain and make sense of the powerful world of Linux file permissions. So here's our game plan. First, we'll tackle the 3 basic permissions. Then, we'll see who actually gets to use them. After that, we'll decode the numbers behind it all, see the chmod command in action, and finally, wrap up with why this is all so incredibly important.
All right, let's start at square one. At the very heart of how Linux handles security, there are just 3 core permissions. These 3 things control literally everything you can possibly do with a file or a folder. You can think of them as the basic action verbs of your system.
And here they are. You've got R for read, W for write, and X for execute. Seems pretty simple, right? But here's the really clever part. It's their numeric values. Read is always 4, write is 2, and execute is 1. This system is the secret sauce for everything else we're about to do. So if you can, try to lock these 3 numbers into your brain. Okay, so we've got the permissions down. That's the what. Now let's talk about the who. See, Linux is smart about this. It doesn't just have one rule for everybody. It breaks users down into 3 distinct categories, so you get really fine-grained control over all your stuff. Every file, every directory has these 3 levels of access. First, you've got the owner. That's usually you, the person who created the file. Then you've got the group, which is, a set of other users that you might want to share access with. And finally, there's others, which is literally every single other account on the entire system. So when you see that long string of 9 characters in your terminal, it always follows this exact order, no exceptions. The first 3 are for the owner, the middle 3 are for the group, and the last 3, that's for others. It's a super consistent and predictable pattern, which makes it easy once you get the hang of it. Okay, this is where it all comes together. This is where we connect those symbols, the R, the W, and the X, with those user groups we just talked about. We're going to translate it all into those 3-digit codes you always see, like 755 or 644. Let's break down this example, which is a really common permission set. We'll take it one chunk at a time, starting with that first triplet, which we now know belongs to the file's owner. So for the owner, we have read, write, and execute. We just take their values and add them up. 4 for read, plus 2 for write, plus 1 for execute. And that gives us our very first digit, 7. The owner gets full control. Moving on to the group, we can see they have read, which is a 4, and write, which is a 2. But see that little dash? That means no permission to execute, so that's a 0. You add 4 plus 2, and there's our second digit, 6.
And last but not least, we have others. In this case, they have permission to read, which is a 4, and permission to execute, which is a 1. Add those 2 together, and you get our final digit, 5.
And just like that, you can see how that symbolic string, RWX, RW-, R-X, translates perfectly into the numeric code 765. It's not complicated, right? Each number represents a whole set of permissions for one of the groups. It's just simple addition, but it gives you incredibly powerful control.
So now you're a pro at reading permissions, but how do you actually change them? Well, for that, you're going to use the chmod command. It's short for change mode, and it's going to be your best friend for managing file access. You will see 755 used all the time, especially for web directories. What it does is give the owner total control, but it lets everyone else read the files and execute them. This is perfect for something like a web server, where you need scripts to run, but you don't want random people modifying your files. Now, for something like a personal document or a system configuration file, 644 is a much more common and, frankly, safer choice. This setup means only the owner can actually change the file. Everyone else can look, but they can't touch. It's great for preventing accidents or malicious edits. And this right here really highlights the massive difference. Using 777 is basically like leaving your front door wide open with a sign that says, "Come on in." Anyone can do anything they want. It's super risky. On the other hand, 644 is like having a good, strong lock on that door. It gives you a really solid layer of protection for your important files. So, after all that, why does this matter so much? I mean, what's the big deal? Well, it's because these permissions aren't just some little administrative feature. They are the absolute bedrock of security and control on any Linux system, period. Look, by getting your permissions right, you're not just organizing your files. You are actively building a fortress around your sensitive data.
You're controlling who can change things, stopping unauthorized access in its tracks, and locking down your entire system. For anyone in development, system administration, or security, this isn't just nice to know. It's absolutely essential.
So now you get it. Understanding file permissions gives you the power to secure your digital world with intention. You literally hold the keys now. So the only question left is, what permissions are you going to check first?